share the screen. I'm sharing a screen already.
Oh,
Just so yeah, that's so. Hi everyone, back from lunch. So this is my demo of Sherlock Holmes books. So I basically downloaded about 100 books from Gutenberg. I didn't use sticker. I did because the documents were in text format already. So I just got that and then indexed it in Fice in-memory index as well as Elasticsearch, and this will give the combined results. So I'm gonna. So that's basically the Streamlit app. It's hitting a Racer API which backs a Fast API. So I made Fast API work with Racer, and then it's getting the results from there. So there are 3 columns here. You can see it's self-explanatory. The first one is the semantic search. It comes from Spice Index. The middle column is from the Elasticsearch Index. And the hybrid is a combination of two. It uses the re-ranker and then ranks the 2 results together. This is the chunk. The chunk size is minimum 100 and maximum 250. I played around a bit with it, and thanks to Asif for helping me with that. Initially, it was very small. I mean, the price index was returning very small results. So I increased it a lot, and then it became huge. And then this is where I arrived at. So these are the font sizes. So let's
also mention the lessons you learned, like for example, cosine versus dot, etc.
Yes, yeah. The important thing there that I learned was thanks to Asif, because I was stuck there for at least for a week. The thing is, when we do the chunking, the price index. So I didn't have a minimum length. So what happened was sometimes the sentence was just 3 words. And then it used to, when I use the cosine similarity function, when I chunk the sentences, cosine actually favors smaller sentences. So on this first column, I used to see like 3-letter words, 2-letter words, and stuff like that. I'm here will be one of the results here. So everything was chunked, but the thing is, it used to select the smaller chunks when I use cosine similarity with a small when I allowed the small size. So that's why I had to set the minimum size and then re-index it, and after that it works much.
So yeah, you are saying that okay, dot product comparison is better for the longer sentences.
Yeah. And I didn't discover that. I played with it, and Asif helped me out with that particular one. Thanks also. And so this is the actual book. And since it's available, I just used the plain text version. There was a library called Gutenberg Pi, which downloads all the books. Downloads the entire catalog and puts it in a MySQL database, or it can also put in this document database. What is that? MongoDB. But I used MySQL, and then I read from that and then did it. So it's a simple. I don't want to do a full walkthrough, but basically. So basically I wrote a simple runner, which will basically go through each step. So this shows all the steps. And then, so the 2 main parts to it, one is the indexing and then the searching part. And then it runs the Racer and the Streamlit application. So that's basically how I structured it. So I didn't use PySpark. So that's what I didn't get to scale it as much. I would have loved to spend more time on it. I had to do other projects, so I couldn't go beyond this. So that's where I am. Any other questions?
Can you show the part where you did the cosine
Yeah.
similarity?
Sure.
How you added a minimum length?
Yeah. So first of all, so I used the INA file because Python had a default way to the INA file for the configuration instead of using YAML. I'm not saying this is the best way. I just did it this way. It's the old school way, I guess, but it worked for me. So here I said I use the minimum chunk size. So I'm going to search for this. Yeah, so this is the dog chunker. And let me go right here. Where do I use it? Yeah, this is where it is. Yeah. So the thing is, I wrote my own code, but I was influenced definitely by Asif's code. It was super helpful. And the FICE part, I just used a lot of his code, like probably 80% I used. But most of the other things I tried to write from scratch. And then if I got stuck, I used to look at the code. So. Does it answer your question?
Yeah. Thank you.
Yeah. Any more questions?
The cross encoder, which cross encoder did you use?
Let me. I mean, the models I used, whatever you used. So those were things that I didn't take the pain of tuning everything. So.
So you said that you downloaded the text file, not the PDF file.
Yeah.
So which means that
text file,
the part is not there. So it is directly like you went into the chunking part.
Yes, that's right. So other learning is so I downloaded it and put it in Azure Blob Storage because it's more durable. And then I use my MariaDB for that and for storing the chunks. And this is
so the original text you put it on the blob.
Yeah. This thing is blocking. I'm not able to. Yeah. Okay. So let me see if the chunks. Yeah. So this is the table. It's pretty straightforward. It's chunks. There is this big thing that's blocking the whole screen for me. So I'm not able to. Yeah, that's better. I got it there. Yeah, it's fine. Yeah, okay, that's what I wanted.
So increase the font a little bit.
Yeah. Yeah, unfortunately, it's yeah, that's the bunch of chunks, and I used so you can see that's the chunk. I mean, 100 to 250 is the size, and I used the table structure that Asif used, which is I have 3 columns for vectorized ANN index and elastic index. And by the way, that's the vector that is used for the embedding. Yeah.
Nice. Did you do the RAG part also for the LLM?
No, I didn't do that part. It's not yet.
This is really good. And the interface looks beautiful.
Oh, yeah.
It's a clean, nice interface. And it works. Do you feel that it works?
Yeah, it works.
Did you feel that the hybrid search gave you better results?
Yeah, it is better. So there are certain things like, so this highlighting, I just use some plain, I split the words and then highlighted them. But you can see that plain text favors a lot of the highlighted words, whereas there is stuff like this, like it selects from other languages, and here gazing after them, and it still selects some results that Elasticsearch wouldn't select. So I noticed that I didn't go deep and look at different things. So yeah, I think next step is to rack this and use Spark and Ray for scaling this more. Yeah, that's what.
Yeah, we use Ray serve to serve the inferences.
Yes.
I love the separation and the highlighting the keywords and referencing the main documents. That's really cool.
Yeah, by the way, Streamlit is super nice. I know React, but I want to learn Streamlit, and it turned out to be really good. Less time to.
So guys, I must say that this is great work, Prasanna. And I must just say something about him. When he came here, this is his first touch with LLMs and AI. He came, there were a whole group of people who came, of which Prasanna is the only one who joined the LLM part. They said other ones were a little bit more cautious. So they wanted to first do the AI and then do the LLM bootcamp. Prasanna was daring enough to jump into both at the same time. And even more daring, he became a one-man team. He did the entire project on his own, while other teams have done it in groups. Prasanna has done the whole thing single-handedly. And this is absolutely incredible progress. Really, this is really very nice. So you are ready, Roman?
Besides, he's presenting. Okay, I don't do it in
Wasn't to sit down.
Yeah.
Chair is for you. You're the teacher now. You have to be closer to the microphone when you talk. You can pull it towards yourself.
Can you all hear me okay?
Oh, you can take this chair.
All right, so can you all see my screen? All right, we thought we'd first give a little slide presentation, and then we'll head over to the room and actually go over the demo. Given As's propensity for poetic language, we thought we'll take advantage of that and actually use that in our agenda. So you'll first go over our topic, the AI data pipeline, how we did the data preparation, how from the query backend communication happens using Fast API and Streamlit, what we did for the prompting, which was actually a lot of fun, how we went about choosing our model, our experience with Ray, and all the lessons learned. So we decided that our topic would be about food. We had about 150 files that contained recipes, food cultures from around the world. And obviously, as we were going through all the books, there was a lot of PDFs, and there was a wish that I had that we could actually do images and PDFs. So I think that information would have been a lot more richer. But then, baby steps. So we started with text, and that's what we ended up dragging. So this is just, we put together a diagram after we started putting all the code together, like just thinking about what we did in our code and writing this, putting together this diagram was actually very interesting, because even while creating the diagram, our understanding wasn't quite aligned. So, getting everybody to see this and say, okay, this is how it actually works, this is how the box is connected, that was actually a very helpful experience. So, once you get the query, you vectorize the query, you do a semantic search. At the same time, you retrieve the files, you prep them, you clean them, take out all the new lines and punctuations. You create the chunks, vectorizing the chunks, creating a fair syntax out of it. And then, at the same time, you're also interfacing with the database. So we initially started with the SQLite, which worked great for our initial baby steps. And then towards the end, we actually moved to Postgres, which had both the vector and the relational databases out. So in the last couple of days, we actually got Elasticsearch working. So the last 2 days was actually quite exciting for us. We finally finished the whole pipeline where we did the re-ranker using the cross encoder. We had our LLM and finally a chatbot response. So we got an end-to-end system working and functional. So for our data preparation, what we did was we used a spacey model. We removed the punctuations in the new line. We used a sentence transformer model for the semantic chunking. We stored the file names chunks in the schema that was required by the project. We followed that. We retrieved the embedding using FES. For the longest time, we were actually using the index flat N2. We finally changed it to HNSW yesterday because we were kind of concerned about the memory. We stored our index to the storage, and mainly because.
What was your experience when you switched over to HNSW? Did you see any degradation in quality of results?
Yes.
You did. Right?
Yes.
There is a way that you need to fix that.
Love to hear that.
Yes. Continue.
So I think FAIRS index normally needs to be stored in memory. I'm not sure,
into a file that it loads into memory. Yes.
Okay. All right. So yes, our team had a back end and a front end. So the back end actually took care of the whole data preparation. And so what that produced was the index and the database, which the front end would take in order to do all the searches. And then this is kind of talking about the front end. So we have like a Streamlit chatbot, and then we backed it up with Fast API. And then again, we kind of use similar functions to vectorize the query. Now, in our prompt, we used the CoStar. So we got results from our Elasticsearch, from our vector search, and then in our system prompt, we actually, the way we set it up was, okay, first use our context. Display that context, then explain that context. Or if you can't find any context, tell us that there is no context, right? I mean, tell us that our RAG had failed, it's fine. So we ended up doing that. We followed the CoStar method, and so we kind of integrated that with the LLM and try to see how that worked out.
Did you find CoStar useful for this?
Yes. It actually helped us in our adversarial attacks, right? We already had the chatbot up and running, so
Yes.
It's just putting it together.
Very good.
So for model auditions, we started using the Ollama framework, and I think we didn't have any experience going to those 4 GPUs, so we thought, okay, let's try to get it working with 1 GPU. The constraint with 1 GPU is limited memory. So that means we couldn't go crazy on that. So we kind of tested. We started with Llama 3. We weren't sure if that we were going to run into memory issues. Then 5.3 got released around the same time. It's only 3.8 billion. Found it was good enough. It's actually fairly good.
It's very good.
So we thought we'll start with the 5.3 model. And so largely the concern was 1 GPU. How do we make it fit? And then we also spent a lot of time getting Ray up and running, mainly because we didn't understand Ray a lot. So it was a steep learning curve, but it was a good one. We got Ray core working, where we parallelized a lot of what was happening on the back end with the whole data preparation, chunking, putting it in the database and whatnot. And then, yeah, a lot of learnings, environment, so just learning the whole, some of us, we are pretty new to coding, Python, everything. So getting the environment up and running took a while. And, even during the little projects that we were doing, everyone would have their own laptop, they'll have the Linux, the Mac, the Windows, get something working somewhere. So, it all eventually integrated and we focused on the server, but, we started out that way. We were, again, because we started in all these systems, we initially had to use just the CPU. And for a while, we were just using the CPU, even though we had the GPU. Finding the right database, I'm sure Jenna worked a lot on that. So she got Elasticsearch working on a separate code base. But then when we were trying to integrate yesterday night, she was having issues.
I mean, in the front end perspective, I was not able to run the Elasticsearch with the security issue. So I had to switch it to Oosh, and then Oosh is a lot lightweighted, I think, and really easy to use compared to Elasticsearch. So we made our use of it.
And then coming to the actual, we finally got most of the 95% of the pieces together, working with the AI data pipeline. And we only started actually testing stuff up late last night, early this morning, and we were seeing a lot of performance. So one experience that we had was we tried 150 files all at once, trying to chunk it, and that was taking forever. But when we were trying to give 5 to 10 files at a time, it was much faster. Accuracy definitely dipped. And I just heard from Prasanna about that, minimum chunk size. We definitely got into that, but it was a problem we didn't actually spend time solving. So we kind of had that issue. But overall, I think we learned a lot. It was a great experience. We certainly need to optimize. Love to start dragging images and tables. I think that's where all the real information is there.
Especially for recipes and for food. It's all tables and images.
Exactly. So we were focused on Ray. We ended up, trying to understand what did we need. We ended up implementing Ray core, but not exactly Ray serve. So that's something we want to add on top of the fast API. And then, extending it over multiple systems.
Nice.
So,
and then we're going to move on over to...
Yeah, we'll move over to the room and you can see a quick demo.
Okay.
Yeah, I'll stop sharing.
Incidentally, I started off with HNSW, but then I went to CLAP.
Yes.
I forgot to mention that. That also improved the business.
Yes. But for that, it creates a lot of memory issues, right? Doesn't it?
No problem. 96 gig.
Oh,
Plus,
okay.
the GPU is 24.
I see.
You didn't notice it.
But it was slow. I just increased the size to like 40 gig for loading a file and then something. So
yeah. No, you have to use HNSW. When you do the RAG, when you come to the advanced, I'll show you exactly how to tune, because enterprise uses fast with HNSW,
right.
And I'll tell you how to use it.
We should probably hit one.
Can you folks see us?
Yes.
Great. So this is the starting page. And just to give a quick example on the front side, what can we make it with? Oh,
Raja, could you please maximize your screen?
Oh, maximize it like that.
Yes.
Okay.
And increase the font size a little bit. On the big screen, it looks a bit slow. Yeah, much better, much better. Yeah. This is good.
Like Vasanthi mentioned, we had ragged a lot of files, and then so we are asking our questions in the domain of food. So if you give like, what can we make with oats? things run in the background and we get a response. Yes, it's a little slow because we have like a lot of data in the background. So
Can I ask a question?
sure.
Ask it. How do you make pumpernickel bagel? How do you make pumpernickel bagel?
Pumpkin.
Pumpernickel bagel. So, the spelling may be wrong. Nikel, but it's okay. Nikel, yeah. Nickel, yeah.
Yeah.
That's all right. Doesn't matter. Let's see what its response really.
Yeah, I think the first one, yeah.
Yeah. We never tested this in this resolution, so
That's the reason I asked you this question. Okay.
so yeah.
Let's see.
It actually, there is a context.
Yeah.
Can you go up higher?
That's the ingredients.
Nice.
Um,
Oh, great, okay.
ingredients. Nice. This looks good. Yeah, this is amazing. Very good.
Yeah, so it does that. So just to give a give some more details. If you see, like when we were trying to do the chunking, we got array working, and you can see some of them got dead and blah blah blah.
Awesome. Pannico.
So let's say if I have to go like some more files, right? Like I can always copy them and add them, and in the background, the process will go and add them to the backend. So it says here total files to process are 5. It knows that hey, all the other files are already processed, kind of a thing. And in the Ray core, yeah, that's
You use Ray core for your compute, like for chunking and
Ray core, yeah, for parallelizing the chunking part of things.
But
all the text processing. So we have used Ray core. We were so if you look here, I think one of the files is a bad file, but if you go here, it was saying, hey, I have already processed all these files. That's why I'm skipping. But in the database, I did not see this particular file. So I'm going to do like globally, it's Pakistan, PF, and medicinal books. So these are new files to me. So I'm going to process for them. You can see for the Ray cluster, there is like it's showing how much compute we have, like 20 CPUs and 1 GPU and things like that. And while we are doing, sorry.
What did you put a watchdog on that directory?
Pardon?
What did you use to observe that directory?
Like a cron job for now. I mean, we could have Jenkins too, but yeah, a cron job. I mean, but it's a longer interval. So right now I have put like a manual trigger. For demo purposes, and we got the rate, like we said, hey, for each process, please use like 4 CPUs and 0.2 GPU kind of a thing for the Ray stuff. And like Vasanthi mentioned, so we have used the CoStar context to get like contextual results. Yeah, that's I think pretty much it. So we are saying, hey, your task is to help me develop a comprehensive system for educating me on food, culture, wisdom. Like we are restricting the domain of things even within food. So only give responses to this, and the response is this, and then we are giving the rules here. And what is the display format? Display the given context as is first. That's why we are seeing the context. Explain your understanding of the context. So this is LLM's understanding of the context, and then it's providing a structure. That is one of the reasons in the answer, right? You're seeing it in a structured, bulleted way because we have mentioned to CoStar that hey, give a structured list of steps if needed. Right. So we are not saying this is like a ultimate professional implementation of stuff, but we have tried to use all the pieces we have learned throughout the last 12 weeks, right? So
This is amazing. This is really very good work.
What's the advantage of racer over the Raycore? Oh, sorry, Raycore over the racer.
the race serve is typically used for microservices for the front end and stuff. So on the Streamlit part of things, we have not used that. Raycore and Ray Data, right? So those are the two. Raycore is primarily used for any kind of actions. It doesn't have to be just LLMs, but any kind of processing to parallelize. And Ray Data was specifically designed to handle data, parallelized data operations.
Yeah, I'll add to that. See, RayServe is essentially a replacement for, let's say, fast API. It's built on fast API. It's GPU-aware serving of inferences. But think of Spark. Whenever you do a parallel data compute, any data computational job, you want to use Ray Data. Both RayServe, Ray Data, the underlying core is the Ray core. Ray core is the one that has the ability to remote and distribute computations. That's the underlying thing. So again, this is absolutely great work, guys. This team had the youngest member. One team member is in 9th grade. Wow. Yeah, and it has some fairly young people. It has some senior people also. It's a fairly almost all of them. In fact, all of them were new to LLMs and to AI. To my knowledge, this was their first exposure to AI. So incredibly good job. All ends done, Zach done, everything done very well. They worked very hard. Almost every day they were here in the afternoons working on their project. Wow. So this is really good dedication, and I look forward to them for part 2. Okay, number 3 is, yes, come by, guys.
No. So after looking at those 2 things, we are backing off.
No, don't back off. Okay?
We are not ready. So basically, like
show whatever you have. Don't worry about it. It's not a beauty contest. You know, it's just, we are all just showing. Come by. Ganges, come by. Don't get discouraged. Come by. The stage is yours. No stage fright. No stage fright allowed. Shrutika, do you also have something?
Well, the thing is, what we're going to present is like pretty. I think it doesn't fulfill.
It's all right.
The project,
but you have something, right? Yeah.
So I mean, I would prefer if we would get a little bit more time to work on it prior to.
There's no time. Today is the last class. Present what you have, and then in the summer work on it a bit more. And the remote people, cover guys, do you have something to present today? Sarah, do you have Ryan? Do you have something to present?
No, we don't have anything to present today. We're still working on it. I was hoping that maybe we could do maybe in the first week of the LLM 2 or something like that. We can show off what we did, something like that. But I don't know if that's available.
That's fine. And Cowboys, how about you? Sanjeev Kumar and Satyakam, are you still there?
Yeah, I'm in here.
Yeah.
So we are
you guys ready to present?
No, I don't think we are absolutely ready to present.
Okay. All right. So we are going to start now with Ganges. I think you are next, Ganges. Come by. Come on, yes.
பிக்கப் பண்ணிக்கலாம் அப்புறம்
இங்க வரும்போது விட்டான்னா சரி அப்படி இல்ல எங்க ஒண்ணு டிராப் பண்றாங்களோ அங்கேருந்து
Okay.
I want him to make him remove that, right? How
What-
God.
కొంచెం కొంచెం నడువులో అమ్మమ్మ ఇల్లేని అదర్వైజ్ వాట్ హ్యాపెన్
Yeah.
Who it is? Who is this? Uh-oh, sorry. How do I? Okay, I muted him. After that, Shrutik, it's you.
No, we both are together.
Oh, you guys are together, all right. And then we'll get this, guys. The Yeti. Get out of the audio altogether. Yes. Go ahead.
So I don't have a
pretty picture.
but this is what our journey is.
So to your audio is entirely
So this is sort of like not a pretty presentation, but this is where we started as a document as a team, what we want to build. So there are a few functional components we picked up. So basically like starting all the way from, I mean, this is like a rough diagram what we had in our board. So basically like extracting the file from the, from the internet, which is like a sort of like a PDF files, HTML or a docx, whatever it could be. So trying kind of like put it in a document store. And then like from there, we want to extract that file using the Spark. Meaning first we want to kind of pass the file using the Apache Tika, and then like extracting the text and putting it into the database. And from there, we want to kind of like read the file using the semantic chunking to do that like embedding. And then after that, like we want to use the vector search to do that like semantic searching, and then present it to that user based on the queries. So that was the whole idea about that. And we want to kind of use all these the tech stack, whatever is proposed by Asif in terms of like how to kind of like use with various technologies. So we try to kind of like do that one. So one area where we thought about was start with like a PDF files from the Gutenberg or any other document, I mean, any other internet stored files. But the overarching goal, what we had was like a building something like relevant to sort of like a community app where we can build, we can scrape the web on all the universities' web pages and bring those data so that like we can have that as our document store. And then like ask the question from there by the user saying that, okay, hey, what are the courses I compare from these three universities? So that way, like I should be able to get all these like relevant data set from three universities according to the courses. So that was our overarching goal, but we are still like kind of building towards that one. Still like the scraping work is happening, but rather like we can start with like a PDF file. So that like we can change the document store from the PDF to this college data information. So we are still working on that one. There are a couple of design choices, or maybe like the functional choices we made was one is we can go with the PostgreSQL instead of like doing the MySQL, just to go to have a different flavor from the partial code was said by Asif. And then the second choice, personally I did was that with the similarity search, right? So I want to do with the cosine search. So basically, I have that result for that. But yeah, exactly like I'm still seeing that, okay, the length of the text after checking. So that's where I was interested that, okay, what was the difference between the dot product as well as like the cosine search. So I need to kind of do the switch on that one. Then rest of the things were like pretty standard, where we are using like a racer. We hit up one area where the racer in conjunction with the spark, I'm having trouble. So basically that I didn't get that work. So what happened was like when we were sort of like reading the text, which is from the database, then we were using the spark to do the semantic chunking. We want to kind of provide that semantic chunking through the spark, but calling the racer to do the chunking part. So if we are kind of doing that both in conjunction or in tandem, the code was not working. So what happened was like the Spark job is like started and it was kind of stalled. Couldn't able to recover. But I can, if I run it like in a separate, just a Spark alone, it is working. I don't know what what is going on there. Yeah, so those are the hiccups we have. So that's based on our like a journey in terms of like what are the things we have tried and how we are kind of like moving forward. But we can do a small demo, okay? Whatever we have put together, but the race service is not running, but the database what we are using is very small corpus. But probably like by next week we'll have a little bit more mature solution. So for today we are going to show that like where we are today, and then where we are going from there. Okay, Shrutik?
Yeah, so
Should it go to this? Because remote people can't hear you.
yeah, so I can't say that it's a whole ton of progress, I guess, compared to the other ones. Kind of hard to top that, but so pretty much where we are in terms of this is I have like a corpus of maybe like 15 documents of just like my old college app essays from when I applied to college and high school. So I think it's a pretty similar architecture to the other ones in terms of having a hybrid search using face and Elasticsearch as a combination of a keyword search and semantic search. So the way this kind of works is we use the schema defined in the documentation for the project, the project instructions. And over here is just kind of like some dummy metadata. I chose to just write some dummy metadata because Apache Tika doesn't give you like, you know, a real sort of like a real world sort of metadata that you could work with. Like, for example, it doesn't give like there's no author tag when you submit like a file URL. So this is some dummy metadata. I tried it earlier with the text length, which is another like piece of actual metadata that Apache Tika gives you, but this is just more so for proof of concept. So a whole ton of random names for potential authors, right? And so pretty standard parsing. We just got the title. We insert it into the document table, and so on and so forth. The semantic chunking portion of it pretty much uses Apache Spark to chunk it. It chunks it by paragraph, I believe, or so. And the way it identifies that is via a new line. Each chunk is then vectorized using SentenceBERT and is then inserted into the chunk table. If we pull up the terminal, you can kind of just see that. You know, chunk ID, the text form of the chunk, and then the vector afterwards. So then what takes place is in the actual indexing, in the actual application. So to indexes are made pretty much, the being a metadata index and a metadata index, a vectorized chunk index, as well as like an index full of the actual text contents of each chunk. So the metadata index and the text content indexes are searched through Elasticsearch. This is the keyword component of the keyword search component of the hybrid search. And then obviously we use face for we created a face index for the semantic search portion of it. So when you just go to the application, if I search up, I applied to Brown University, for example. So if I search up the word Brown and I have a subject search, then it'll return the top 10 most relevant searches. And this score is pretty much a normalized. So whenever you do any search in face or semantic search, it returns a score. So these scores are normalized, essentially made from like 0 to 1 on both scales and then added up together so that search results with both the keyword and semantic similarity are moved to the top. And as you can see, you have search results on that end. If you do an author keyword search, for example, if I type in, I believe one of the authors was like John Doe. So if I type that in, you also get document ID and the file name returned. So yeah, that's pretty much where we are right now. So yeah.
So you haven't grabbed it yet. Yeah, you can yet to. So again, great presentation, guys. These folks have been struggling for quite some time. Actually, the fact that they reached this far, despite not having good hardware, they had a lot of struggles with the hardware. Only recently did we give them a totally new. How is the new hardware doing, Grace Hopper?
We have not started on that.
You have not started on that hardware. Okay, you lose it then. You don't get it for some.
Got it like what, last week?
Okay, yeah. You still have to set it up. Apologize, but yes, the next group, I suppose, are the Bigfoots. Yeti, the book Bigfoot. Are you guys still with me?
Yeah, can you hear us?
Yes, we can hear you. Can I ask you if anybody is size 30 foot, shoe size 30, Bigfoot?
No, size 13. Size 10 is what I am. I don't know about anybody else who has more. But we never know.
Sorry for the bad joke.
That's a good joke. So, all right. So what we are, to be honest with you, we weren't prepared to present today. We didn't think that we thought that we were gonna take a few more days to kind of put everything together. We have sort of have some bits and pieces of the solution working, but nothing has kind of, we don't have anything end to end that kind of works that we could show. We had done some POCs earlier in the process, and then we kept adding more stuff to it. For example, we then added the array, then we added the the database. We added the database first, then we added the array, and then we added the Elasticsearch. And then lately, we've also been kind of experimenting with adding the LLM to kind of summarize the results and all that. So we have all the components, and some of them are working in isolation, but we don't have anything sort of end to end so far. So that's something we plan to do, continue working after this class. So today, what we will do is we will sort of just give an overview of what the system architecture is, for how the different components that we have chosen and how they kind of fit together. based on our understanding, and then we'll walk you through, the team will walk you through some of the code that we have implemented on the server side, and then some of the client side code, along with the hybrid search and the LLM that we are planning to integrate. So Shant, if you want to kind of just walk us through the slides.
Yeah, so let's just get started with the system architecture, the thought process in the system architecture. And so basically we did the design that as a data pipeline. So we process the data in different stages. We get the data, we have a lot of files, which actually we have stored it in one folder. And that folder is basically to be processed folder. And then from that, we move it into the database. We extract the text, whether it is a PDF or any other format. We extract the text and move it into the database. We are using Postgres database for this one. Initially, we started with SQLite, and then eventually we moved it to Postgres database so that we can actually horizontally scale the database. And we are also collecting different metrics about the data processing pipeline. Like say, for example, when we actually do the extraction, we collect the time, how much it took to do the extraction. Then when we do the chunking, we are actually collecting the time for chunking. And eventually, I mean, once we have the full system, we can actually compare with, we can even try comparing with the different chunking mechanisms and stuff like that. So we collect how many milliseconds and stuff like that. For vectorizing, we are doing the same thing. And we are using a scale-out architecture in the database, meaning we can technically have, say hundreds of servers. We are processing 1 million documents, and we have hundreds of servers which are scaled out as part of the database. We can actually process these tables into different databases. So we have horizontally scaled the architecture. And for processing, we are using Ray, and that is also scaling horizontally. We do not have fully parameterized, we still need to do a little bit more research on, the number of GPUs and stuff like that. But we have the Ray serve running, and we are parallelly processing the chunks. We are able to do that. And as a whole, we are doing a microservices architecture where different services are provided for different services, which is mentioned above. So roughly, this is the system backend, where we have the document any format, which is actually moved. Well, that was the first connection to the text extractor. That connection shouldn't be there. I think we got too enthusiastic about connecting everything. So that it goes into the text extraction is done, and that goes into the Postgres database. And then we have a different service which chunks that text and puts back into the Postgres database. Same thing with Vectorizer. So initially we were thinking, we actually went with multiple iterations of this. We had multiple versions of POC. And then the production version also, we actually went with multiple iterations where initially we thought we can have a separate service for vectorizing. But then that actually incurs an extra read from the database and writing back into the database. So then we actually decided to both chunk and vectorize at the same time and writing those two together into the database. So that actually avoids some database overhead. And so then after vectorizing, in the production version, we haven't moved it to the phase yet, but we have the phase running as part of the POC. And so this is the architecture we are thinking about, the inference and the hybrid search and LLMs. Shyam, do you know?
Yeah.
Yeah, you're unmuted.
Yeah, basically we have a POC working. We are working on making it production grade. So what happens here is the query comes in. So the query comes in. So this path is our regular, we convert it into embedding and then do a nearest neighbor search and get the top 5 result. At the same time, it will do a lookup in Elasticsearch and finally this top 5 from both results are loaded into re-ranker, which gives top 3 output. It assigns score for every result, and based on that, we sort it and get the best result out of it, and then load it to LLM to get a final output in natural language. So definitely Elasticsearch increased the accuracy of search results, and the re-ranker gave the better results. I think we still need to do some kind of optimization in this area. I felt like the results are not great. Maybe the chunker is not good, or the FOIS algorithm is not good. We are using index flat too. Do you have any suggestions, Asif, on that? Do we need to play with the FOIS
No,
algorithm?
you need to use, you should move to use two things, HNSW and IBM. Play with those two. When you play with those two, what happens is that your accuracy will slightly dip. But because you have a re-ranker, get more results. Let's say that you use HNSW, get a much larger set of results from there, like you get 20, 25 results, and then sieve it through the re-ranker.
Okay. Okay. Definitely adding this helped with the result, but we need some kind of optimization here. Adding Elasticsearch and re-ranker added more value to the project.
Very good. This is really nice.
Yeah.
Want to talk through that?
And
Go ahead.
yeah, and we made use of Ray extensively, and we could make it process parallelly and make use of multiple codes while processing.
Did you use Ray data for backend processing?
No.
Ray core, directly Ray core.
Yes.
Yeah, Ray serve, I think. Ray core and Ray serve.
Ray serve is for inferences, but for the text, like text extraction.
Text extraction is Ray serve, basically. Multiple of them. You can run any number of programmable number of them running in parallel.
Okay. But you didn't, so you mostly use Ray serve. You didn't use the Ray remote, like direct Ray core.
No.
Using.
Oh yeah.
We are using Ray remote, Asif.
You are using
Ray serve, yes.
Yeah. Okay, very good.
So actually, in one of the things where we process the data, we send it to the chunker, right?
Yeah.
So sending it to the chunker, we do the Ray remote, but then we didn't want to wait for everything to come because it can actually hog the memory. So what we did is a ray.wait, where we actually wait for each one to come, and as soon as we get one thing at a time, we process that and put it into the database.
Okay, very good, very nice.
That's actually a key point. It's completely the chunking is totally non-blocking. It ties back to what Sushant said about the parallel, scale out architecture and databases and all this. This is all working end to end. That part, the chunking part.
Very nice.
I just wanted to add, we are also thinking just adding some sort of a security guard right before the LLM again to be done, but kind of do that integration also. That will make it really sort of enterprise grade, correct? Put a bounding box around what you can query.
That's a very good idea. Very good idea. Put Llama guard there.
Yeah, again, we just have to string several pieces. We have individual pieces done, but I think goal is next 2-3 weeks, and we can do a demo to you as if separately.
Sure.
Or anybody else interested, of course. Yeah.
question. What is your topic?
World War II.
What's your topic?
Historical World War II is what we have. We have downloaded a bunch of data set on the web, but again, it's not integrated with this code yet.
Yeah, in fact, I would say two parallel ones. The other one is still we have to experiment, but sort of, Bhagavad Gita available in public, but with some spiritual teaching from spiritual master, which are more private data. But work has to be done to validate how well it works.
Nice, do those. Ramki, do those things.
Yeah, absolutely. Sorry, I just got hammered by the worst this work episodes last three months had to manage. But I think the team, as a team, I think other people also got into many challenges. I can see that.
So just wanted to show the database, how we kind of scaled out, as we have two separate databases here. One is semantic search and the other is the semantic chunk. Right? So semantic search is pretty straightforward. We have just a single table with so here we have the text extracted time and chunking time and encoding time, etc. So we also have the file hash, so we actually don't reprocess the files. So we are taking the SHA-512 of each file and storing it so that we don't reprocess it. Even if we happen to rename the file, it still should take care of that. And then we have a semantic chunk database schema where we actually create separate tables for each file, so which actually becomes much faster, and we can actually store the semantic chunks into scale it out into multiple servers across IP addresses, and so that way it's much more.
Okay, so Shant, I have a question for you.
Yes.
Let's just say that you took I'm asking you because you mentioned SHA hash. You hash it. A new file comes. How do you check that it has already been processed on it? You'll compute its SHA hash, and then you will look where. Where do you keep the set of all SHA hashes?
So the hash is computed in for each file when we process, right? So we have the folder where all the files are there. Now we take, once we process it, to be processed folder. Unfortunately, my laptop died, but we have all the files coming into the to be processed folder. And we, as and when we are processing, we take the SHA-512 and store it into the database and do the text extraction at the same time.
Well, that is all right. But suppose I get a file. It happens to be a duplicate. Like, let's say that it has a different name, but the content is the same as another file that you already have. How would you detect it? You would do the SHA hash to compare. Do you write a SQL query to see if it exists?
Correct.
Don't do that. That is not scalable. Imagine that you have 1 billion such items in the database. How would you realize that you're doing a full table scan? From a database perspective, you're doing a full table scan at that moment. So the right thing to do.
We can create an index on that.
Yeah, but that can be a primary key, right? That would be efficient. Isn't that true? If you have it as a primary key, correct?
No. See, suppose you make it a primary key, put an index, whatever. The primary key is an index. What do? Your SHA hash is a string. It doesn't have a structure to it.
Right.
So indexing is not going to be efficient. Try it out. You'll see that. Indexing may help a little bit. It's not a really efficient way. You realize. So what can you do? There is a data structure called the Bloom filter. What you need to do, anybody knows about the Bloom filter? Prasanna will tell us what a Bloom filter is.
Yeah, from 20 years ago, I vaguely remember.
What's a Bloom filter, Prasanna?
So Bloom filter is a data set where you basically, it's a bitmap. You take a string and then keep putting it, setting bits in the bitmap using an algorithm. And then it's used for the situation where you want to say if a particular string is in the in the bitmap or not. And it favors false positives or false negatives. I forgot that part. Which one?
It can have false positives.
Yeah.
Yep.
False. So basically, as a real world example is in the Chrome browser, if you type a site that is malicious, then Chrome uses a Bloom filter to figure out that, hey, the website you typed is in the Bloom filter, so it is a suspected site, so stop it. And why that is important is you don't want to go hit the server every time you type a website URL. It's cached in memory and it's used. So that's good. That's it.
That's correct. That's perfectly correct. Prasanna, thank you for that great explanation. Bloom filter is a probabilistic. It belongs to a class of algorithms called the sketching algorithms. What they do is, for example, if you have 1 billion items, it will still return in sub-milliseconds. And the reason is, Bloom filters are all over there on the internet. They are in networking gear. So I expected some Cisco guys to speak up.
No, I mean, I was raising my hand.
Oh, you
So
were.
pretty much.
Yes. Okay. Okay. Yeah. So it runs at the speed. You can do close to 1 million inferences a second. It has extremely high throughput. What the problem with Bloom filter is, it uses a very fixed site sketchpad or bitmap to look up. It has a couple of false positives, very rare false positive. So what you do is, if you don't find it in the Bloom filter, you can be sure that that document does not exist, which will be the situation most of the time. But in case you find that it exists, you know that it can be a false positive. That would be the only time you would run a SQL query to validate it, to be sure that it exists in the Bloom filter, because you can have a false positive. Okay. Are we together? Yeah. So use a Bloom filter, guys. Bloom filter is one of the least celebrated gems of our algorithmic world. Use it. There are many such things. The whole field of sketching algorithms are like absolutely marvels that most people don't know about.
And probably, Asif, we'll have to do a distributed implementation of the Bloom filter, right? Because, I mean, we're scaling out actually something to...
Bloom filters are tiny. Each node can have its own copy of the Bloom filter.
All I'm saying is we have to populate the Bloom filter. Some work is involved. It's not like it's only one copy. Some work is
but you do one table scan to populate the Bloom filter.
Correct. Makes sense. Whenever we complete the chunking, we can, the file, text extraction itself, we can put it actually at the end of it, populate each node.
Yeah. And Bloom filters are additive. They have their additive property. And because of that, they're massive. Once you start noticing Bloom filter, you'll see them everywhere. All right. Very good job. Please continue. When is the demo?
So we don't have we only have the POC, but I don't know if we have anything that we can show.
Actually, we have an end-to-end solution working. But what happened was, it's in my laptop, which I integrated with Llama 2, and it's struggling to produce output. It takes.
That's all right. Show the UI.
So we can show
I can show the
client
code
side. Shyam can walk you through the client side of it.
Yeah.
Zoom.
So Asif, when they bring that up, the question is, in the code base, we are using like a Spark and then Ray in a couple of places.
Mm-hmm.
So is that the normal architecture we need to follow?
Gradually forget Spark. Just stay pure Ray.
Okay.
The only reason I gave Spark is because in the first LLM, a lot of people are very scared of Ray. And they said, we'll do anything, but don't make us do Ray. So I said, okay, compute with Spark and do your inferences with Fast API.
Okay. Because I don't, the problem what I'm encountering is like, if I run like a Spark and Ray together.
Yeah. Ditch Spark altogether. See, Spark still has some oxygen left, some life left, because you can do SQL, Spark SQL, which Ray doesn't support. So in the general purpose data computation, Spark is still stronger. But for the AI people, AI crowd, they should completely move to Ray.
Okay.
Go ahead.
Yeah. This is our code with end-to-end implementation. So basically it starts with, we are starting init Ray, initializing Ray, and then first creating the database here. And then what this does is it goes through the directory and read all the files and creates a list out of it. And that is where Ray comes in. Basically, these are the processes: convert doc to text, text to the chunk, chunk to embedding, and embedding to etcd, right? And here we are processing it with ray.get, and we are calling the remote function of this with all the files. So basically this doc to text conversion runs parallelly across all the cores available. And similarly, once this is done, text to chunk is also running parallelly across all the cores. And that is how we complete all the files till here. And then, and this is the inference part where we are waiting for query. We need to integrate the Streamlit part and run it as a server. But basically what we are doing is we are doing the like searching the FICE index and getting an output. At the same time, we are doing elastic search of the query and getting the output, and then feeding both into the cross encoder. And this is the model that I found. Maybe there are other models.
This is a small model. It gets the job done. You will get much better accuracy with a slightly bigger model, but this is good.
But this itself gave a better result, is what I
it's very good.
Yeah. And then finally, yeah, this is the step which my CPU is hogging, Llama 2. And we are providing the context to give output only from what we are feeding as input. And yeah, it takes the query and gets the output.
Very nice. This is good. This is very well done. Great job, guys. One of these days, when it is ready, then demo it again.
Yeah, sure. Yeah, we are working on making it production grade in our lab, in our machine.
Very nice. So thank you for this presentation, and guys, a big clap for them.
Thank you.
So as if we were able to do that in spite of not having the young kids here.
Youngsters here. You mean all the gray beards still do it?
Yes.
Yes. Okay. Yeah, guys, I must say for all the Yeti, the Bigfoots, that they worked really hard. There's another team that would be here practically every day and working hard. Likewise, Ganges team, the Heisenbergs. One thing that I found with this cohort is the incredible dedication. Many of the teams brought a huge dedication, and it was really a pleasure to see them here every day, or almost every day, working hard at their projects and making progress. This was just amazing.
Thank you, Asif, for all the guidance.
Yeah, I really appreciate all your input and guidance.
Absolutely. Just a question, Asif, like you're mentioning this popularity of Spark, right?
Yeah.
I mean, if then
I can't hear you clearly. Your voice is slipping off.
No, what I meant was you meant if enterprises are moving to Ray and they will for AI, then Spark will slowly die off, right? Correct?
Nothing ever dies off in the industry. See, guys, Spark has a deep penetration. There are millions of developers probably doing Spark, or hundreds of thousands of developers.
I see. It's that.
Okay. It's a deep technical stack. It does many things very well. Databricks uses it. It's foundational for them. They have integrated it. I mean, it has become the de facto engine for ETL, extraction, transformation, ETL jobs, right? And data wrangling jobs at scale. So Spark is not going anywhere. It's definitely going to dominate the non-AI shops. When it comes to AI itself, See, AI teams are just one or two teams. Rest of them are all standard engineering teams. They will all swear by Spark. See, today you can get a Spark engineer. You can, like, if you advertise for Spark job, 100 people will apply. Or try creating an opening for a Ray job and see how many people are able to apply. Right? Very few. Talent is very, very scarce, guys. That's one reason I tell you guys to do Ray, because to the extent that we are all also trying to upskill our careers, learn new things, I can guarantee you, if you know nothing, no AI whatsoever, you just go master Spark, master Ray. There is a job for you in any geography which is in the 90th percentile of the salary bracket. Anybody would like to vouch for that there are not that many? Yes, there you go. Yeah, it is the experience, guys. So Ray, one reason I encourage you to do Ray is you're picking up highly monetizable skills and key differentiators for yourself.
There are not much articles on Ray. We literally have to read
That is
the code and
yeah, do that. Guys, if for heaven's sake, all the skills that you have picked up, go today, update your LinkedIn profile. Write that you use Ray to create a Ray cluster, Ray serve, Ray, all of this is part of your skill set. Sit back, relax, brew a nice new pot of coffee, and then come back to your LinkedIn and see how many recruiters are chasing you already.
only our own managers might also start.
Your managers will start.
Why did you update suddenly?
Why is your LinkedIn updated? Yeah.
Asif, I have a question. So from the basic product, like if you're building a product, new product from scratch,
yeah,
it even makes sense to like even look at architectures like Java or Java code, or it's better to just start off with Python and move everything into Python and Ray? What is
No, don't do that. See, Java is an industrial backbone. The kind of debugging, robustness, scalability, performance you get with Java, Python is 2 orders of magnitude slower. You can't get that. Java is here to stay for non. Now, trouble with Java is the young kids are all moving to Python because colleges are now using Python to teach, which is great because now Java talent is hard to find. And they actually see jobs are all by supply and demand curve. Python supply is near infinite. You throw a stone anywhere, it will hit a guy who will say, I know Python. Right? The Java is becoming scarce. C++ is even more scarce. Today, what is PyTorch written in? C++. What's TensorFlow written in? C++. Right? Right. What is scikit? Behind NumPy is Fortran. Right? How much talent can you find for Fortran? Many people tell me, oh, Fortran, it is an ancient language. People don't know that some of the deepest scientific work is even today being written in Fortran, right? You have Fortran skills, there is a job for you everywhere. Go ahead.
Yeah, I saw some Autodesk companies like that still use Fortran.
Yeah. What are you saying, Autodesk? I'm talking about national security, your nuclear missiles and all the nuclear, the fusion implosion simulations, and isn't Fortran your ocean current simulation and modeling and atmospheric modeling? Everything is done in Fortran. It's the only language, it's the only true language to do those things in, right? C++, talent is getting scarce. You know C++, companies, like people like Google will advertise a job with C++ talent needed. And literally a handful of people will apply. Everybody wants to join Google and they want to join Google after learning Python.
I recently read that there is a high demand for mainframe COBOL.
Exactly, COBOL is in high demand. Exactly. See, guys,
for last 8 months,
yeah,
we have been trying to hire a PHP engineer.
A PHP engineer, yeah, they're hard to find. Yeah,
You
exactly.
could not get anyone, and even if someone applied, as soon as you say this is like hardcore PHP, they said sorry, we are withdrawing our.
Yeah.
I don't want you.
I think the next 6 months, probably like all this language will be like, I mean, all these models will be trying to do this like a Fortran, PHP and all these things, so.
Yeah. Guys, see, here's the thing. If you are a gray, and this is a message for the graybeards, right? All the graybeards like me out there, right? Hold on to your C, C++ and Fortran skills. They are in high demand, number one. And secondly, get ahead of the curve. You guys have learned to work hard. Youngsters are yet to learn that. They may be quick, but they haven't learned persistence and hard work yet. Go pick up deep skills in Rust, because Python is just a transitional language. Everybody is moving to Rust. People just don't know it. Right? And by the way, when you come in fall and you do the LLM2, I'll make you do it in Rust.
It's actually replacing C++.
Also replacing C++. See, the Linux kernel, Linus Torvalds could not accept any other language in the code base. He's very strict with the Linux code base, right? But the only language other than C that he has not even allowed C++. The only language in which he has allowed some kernel modules to be written is Rust.
So Asif, so is there like a best practice guidance in terms of like this type of code best suited for Python, like prototyping, etc.? Just an example. And this type of industrial scale is for C++ and Java.
Oh, yeah, definitely. See, for every problem, there is some language that is optimized to solve it efficiently, because libraries exist in that language to solve it. So we can have that discussion. When I talk about those Python best practices, I'll talk about some of it.
Thank you.
All right, guys. Yeah. Any other team that's waiting to present? Anyone else?
Asif, for cowboys, we will take our time because we are a little late. So,
Sure.
But eventually we will present.
Yeah. How far along are you in general?
No, we are not yet kicked off because we had our own hammered by our own individual jobs, and we literally didn't have any time.
That's okay. You have all of summer, remember?
Yeah.
Take all of summer. Are you guys planning to take the LLM too?
We'll discuss with you, Asif, and then we'll go. Yeah.
All right.
So I have one question related in that context. So the MTEM, the dashboard. So in terms of like selecting these models, for example, like doing the chunking, so your partial code suggested that okay, with the spacey. So how do you go about this MTEM dashboard?
Oh yeah, those
those
things you'll learn when we do the RAG in depth next time. We'll talk about the MTEP. So Ganges is talking about the MTEP leaderboard and deciding which model to pick, for example, for embedding and so on and so forth. So I'll give you a few rough and ready rules because it's a topic we'll discuss in detail. Don't take a causal model. Don't take a decoder-based model or LLM. It will be a huge model, 30 gigs, 25 gigs, all to do embeddings. Not worth it. The price is not worth it. Use an encoder-based model, right? You can identify them because they'll be of the size of 1-2 gigs at most, right? And for embedding, just pick some. BGE is at this moment doing very well. Now, and you will learn about this. For embedding, in particular, it's worth taking models that have a Matroska embedding. What it means is it does nested embedding. You know the Russian dolls, the Matroska dolls? One doll inside another doll inside another. So I haven't talked about the topic of Matroska embedding. I sneaked it into your course portal. It's there. The article is there. You can read it on your own, but I'll cover it in great depth when we come to the next bootcamp. So the idea is that, see, it is the speed versus accuracy trade-off. When you dip into a fast index, one of the bottlenecks you will have is if your index is huge, like the vector is large, it's 1,000 or 2,000 dimension. It defeats the purpose because let's whatever indexing you use, let's say that you use L2 flat, which of course would be the worst performance because it's not approximate, it's an exact match. You realize that you are doing a massive computation just to find neighbors. So what do you want to do? You want to take a much shorter embedding, right? And Matroska embeddings are very good because they condense much of the accuracy in the first few bits, the first few dimensions, not bits, dimensions. The first few hundred dimensions will contain almost all the information, and then it expands out. So then and that brings us to the deep topic of whether we use IVF, whether we use HNSW, whether we use etc. Because now you're talking at scale. And how do you, so there are multiple ways to look at it. You want to use the shortest vector length indexed in the most efficient way to get a large number of search results very quickly. And then once you get those, then you want to pass it through a cross encoder. Right? That is the right approach. The wrong approach is to go to the MTEB leaderboard, pick the number one, a massive LLM based encoder, and say, wow, it's the winner in the leaderboard. I'm going to use this. If you do that, you'll find that you're making multiple trips to the hardware store to buy more and more GPUs. Right? So that's the way to look at it.
Because when we are sort of like looking at it, like we had that as one of the design consideration to kind of go through that like a MTEB leaderboard and then like find out like which model to use. But by looking at that one, we're clearly able to figure out which is the right one because whether
you learn that. Ganges, you know that this one was broad. LLM 1 was broad. You realize that we covered a vast territory. And yet, if you think about it, you learned a lot of things. For example, big open source, industrial strength open source projects, Llama Index, you practically built on your own just about everything they contain, or most of the essential pieces that they contain. Isn't it amazing that you did on your own? Yeah. So you won't feel that, oh, it's magic. Look, I can use this open source. You built it from scratch. Right? So we went broad, but we went deep enough. Now is the question of coming state of the art. The purpose of LLM2 would be every topic that we cover hereafter, you will go out of the gate being the state of the art, right? Or beating the state of the art. That will be the benchmark with which we'll judge going forward. Any comments, guys? Any questions? Thank you for all the presentations. It was fun. All right, guys, if there are no more questions, it's time to wrap up. I have a request. I'll put up a little survey, which I didn't get time to create. If possible, fill out that survey on your course portal. And you'll also find your certificates on the course portal. Give me a week to unwind a little bit, and then you'll find a nice, beautiful certificate on your course portal. And if for those of you who come here physically, there'll be a nice glossy printout of it.
Yes. Nice.
All right, guys. With those words, I end the lab part of this workshop also.
Subconsciously, we might turn up here next Sunday morning.
You're in the habit of it, yes. All right, guys. So thank you.
Thank you.
Thank you, Asif.
Thank you so much, Asif.
Yeah, you're welcome.
Knowledge community.
Come again?
If anyone is hiring the subjects we learned,
we are the 90th percentile of the AI community.
Oh, thank you.
Asif, I did have one.
No, yeah. Go ahead, Ryan.
I just had one question. How long will we maintain access to the course portal support vectors? Is that
the support vectors course portal? Yeah. You'll have access till we get hacked.
Okay.
So assuming that we won't get hacked, which I hope they are web backers, you have indefinite access.
Okay, very good. And then if we do have some questions as we're working on things over the next couple of months, what is the best channel for us to ask those questions?
The same Slack channel.
Okay. That was everything. So thank you so much for all of your time and instruction.
Yeah, thank you, Ryan. And I hope you benefited from this course.
It's been very, very insightful. We're looking forward to round 2 in the fall.
Hey, Asif, next Sunday we can come. I can come, right?
Yeah, you guys can all come. Keep coming, guys. This place will be open every afternoon. Afternoon till late evening, it's always open.
Okay, what time usually?
Just give me a call to make sure that I'm here. I'm typically here by between 12 and 12:30.
Okay.
All right. All right, guys. Bye then.
Thank you, Asif. It was great. It was great. We continue to learn. I'll be in touch with you more from here on. This is a start.
Yes. It's a long journey. You'll come out experts.